I'm Mike Jura with the Tioga County Soil and Water Conservation District, and I'm here today at Long Creek. This is a site that we recently completed a post-flood emergency stream intervention project on to prevent the stream from continuing to erode in this yard next to me and bypass the bridge on the road just below us here. I'm going to present to you the field portion of the Upper Susquehanna Coalition's post-flood emergency stream intervention training. And typically in a live setting, day one would be at the end of classroom session. We would come out and walk the site, survey the damages, and talk about the planning. Day two, you would come out while work is being performed and take a look at what's going on, and again talk about the planning and pitfalls and changes and things. And day three, where we'd come and review the site after it's been completed and talk about what we've done, why we made any changes, lessons learned, and that sort of thing. And ideally, after we've had some sort of flow event, we can identify what changes or adjustments the stream itself has made. So we're going to do this virtually, and I'm going to try to answer a lot of the questions that we normally get in the field, as that back and forth discussion is usually a high point of the training. So we're going to do our best to anticipate some of those questions, and let's take a look at it, and we'll get started by looking at the drone footage from the damaged site in the beginning.
Okay, well, here we are in the office, and we're going to go over some of the project slides from our emergency stream intervention project here on Long Creek. And Mike Lovegreen, the stream team leader for the Upper Susquehanna Coalition, is here with me as well, and he's going to interject throughout with some additional information, and we'll probably have some back and forth discussion. So again, this is the field portion, where in the live setting, we would be going out to the field and taking a walk of the site at the end of the first day of classroom session and talking about the issues and the problems on the stream. And then following through day two, showing up during construction. And the final day would be after construction is complete and talking about kind of what happened with the stream, what it looks like, why we did what we did. So the objective from this segment of the training really is that you'll walk away with the higher confidence and level of ability to evaluate, assess your sites, evaluate your sites for prioritizing, planning the work that needs to be done, doing the actual construction, overseeing the construction, getting it done, and then the follow-up afterwards. So let's get right into kind of the tour of the site. And before we do that, the flood response, we'll do a little quick review of the flood response from a little while ago in the training. Is we're looking at, here we are looking at the high priority items. You've already addressed those immediate priority items, like during or directly after that flood event. Those immediate priority items are the potential immediate loss of human life, the reopening roads or closing roads in the case of a complete washout, making it so emergency services can continue to operate. And then the high priority items is kind of where we're at now, is we're evaluating the sites and we're prioritizing. So that high priority and the assessment of those sites, if you have multiple sites, you want to, which ones are more important to get on right away, looking at where to work, where not to work, and that sort of thing. Ultimately, one of the main points of this is, environmental protection, of course, but this is going to save you time, money, and resources after a flood event. So being able to properly evaluate and assess sites and prioritize them, whether you should work somewhere or not, number one, what type of work needs to be done and how much work is going to save you that time and money in the long run. And, then the documenting of further needs, we're going to go through the post-flood itemization sheet and how to work that and come up with your documentation of your further needs. So here's the post-flood itemization sheet, and this we've drawn it up specific to our site. You can see here are the questions that we want to ask ourselves. What's the issue? What is it? That's why are we here? What are we looking at? And in this case, you can see that this eroded bank is heading directly towards the road, and if it's not addressed, we risk bypassing the bridge. What needs to be done? How far do we go? What type of work? What is the labor and equipment needs? So this sheet kind of gets you started, and then later on you can use this sheet as you're planning and to help with permit process, and in the long run for recording, how much work was done and the labor force and that sort of thing. So now we're getting into sort of like our walkthrough of the site. And we've got a bunch of this aerial drone footage that gives us a really good overview of the site. You could see here, you could see this from driving by on Penn Ave, that there was severe erosion, that it was a risk to the road. Although it's not directly at the road, both myself and the DPW person in charge of this recognized the need to get on this right away, because without any intervention, this would continue to erode towards the road and essentially bypass the bridge. So that was the initial kind of assessment, is like driving by and seeing that there's a problem there. And then here's a photo of us actually walking out and taking a look at the site. And you can see, what a large washout has occurred, and the stream is essentially trying to recreate its dimensions, and it's not aligned with the bridge whatsoever. So we're here talking about what do we do here? Well, let's get some of that gravel from the other side and fill this hole up. Like, it doesn't really look like there's enough there to get it back up to grade and to realign the stream properly. So, we've got to take a look upstream. And this is from a photo from in-stream looking upstream. You can see the flow coming from upstream is directing the water right into that washout, hence part of the reason that it occurred to begin with. And so, if we don't address that, we can refill this entire embankment here, which was the original stream bank. But if we don't address what's occurring just upstream of it, we run the risk of all that work just immediately washing out again in another storm event. So this is just the aerial view with the arrow showing, what that last slide was showing, is that the flow is directed because of the excessive tortuous meanders that are occurring here. It's just going to want to wash out whatever we put right in there. Even if we had the resources and the time to fill that in and put riprap, our riprap is at risk of failing as well because of that direct force going right straight into it there. So, we want to start looking upstream a little bit, and, also where are we going to source some more material to fill that hole with? Because if we don't fill that hole properly, then we run the risk of it just eroding around and over top as well. So this is the gravel bar just upstream there. We wouldn't necessarily be concerned with this in and of itself, but because it's causing the stream to flow so tortuously and bring this flow directly into the lower bank, two things here is, like, there's opportunity to steal some of that material to fill the hole down below, and we need to look at the alignment of the stream. And like throughout the training, we've talked about streams need to meander. That's one of the ways that streams balance their energies. So we want the stream to have these meanders, remembering that the meandering is a way for the stream to lessen its slope so it can reduce some of that powerful velocity and energy. So, we want to see that, but in this case, because there's been such a kind of a shakeup with the amount of sediment and the amount of meandering, it's causing problems for us because of our alignment with the bridge. So, we want to think about that as we're walking upstream. We don't want to just doze a straight path and berm it up on both sides to make it align with the bridge, because that has a host of a whole other number of problems that could occur. So we want to try to balance what the stream wants to do with what we need it to do, which is realign back with the bridge and be able to carry that sediment and the water flow through without causing excessive damages. So, looking at that next curve upstream, we have the same issue, is that flow is directed right into that bank, and that's causing it to turn that bank and essentially be coming straight back into the washed out section. So we have to keep walking upstream and keep looking to see what's going on. And this is, one of the biggest questions of anytime you get in a stream, and whether it's an emergency stream intervention or whether it's a maintenance issue around a bridge or a culvert, how far do you go? Like, what do you really need to do? And so now we're already walking quite a ways away from the bridge, but at this stage, we're evaluating the site, we're assessing the site. So let's try to figure out what's going on before we determine how far we go, right? So we might, maybe we don't do anything on this bank, maybe we do, but we have to understand what's really happening. So, as we head upstream, there's the next gravel bar. Again, all of this is natural. The point bars forming, the channel having some potentially raw banks on the outside of the bends. None of this is totally abnormal or unnatural, but because of the huge amount of sediment that's in this stream from recent flooding events, it's causing some extra problems. And you can see on the right bank here that there was a buffer of mature trees that now are gone, and it's beginning to erode into this cornfield. So we want to really take a look at that. And here you can see that, there are some of those trees jammed up against the bank there, and no vegetation on top of the bank right into that cornfield. So that's potentially likely to continue to erode into the cornfield and become more severe. Those trees have the potential to become mobile in another flood event and get down to the bridge. In addition, when you look to the left of this photo, you can see how high that gravel bar is. Essentially, that gravel bar has deposited so high that is technically cut the stream off from its own floodplain. So now all the water is forced to kind of stay in that channel, which gives it a lot more energy for more lateral migration or potential down cutting or head cutting. So there's a whole number of things that could be occurring here, and we want to kind of keep our eye on all that sort of stuff. So another point I want to make about this slide is that these trees here in the bank, like, we can use these if we're going to do work. We can use these for root balls and for some additional stability in any new bank construction that we do. And also, Mike walked this site with me. Actually, it was this day that we walked it, I believe, when we did the drone flight. And so far we hadn't seen any undisturbed or healthy segment of stream to try to get an idea of what the bank full dimension should be. But here we noticed, even though this is a very disturbed and damaged section, we noticed that there was a sort of a bench forming on either side of the channel here, and within this larger corridor, and that it kind of looked like it was on the downside of the storm starting to try to reform that bank full dimension. So we took a measurement here just to check with, and we recorded that, so when we look back in the office, we can compare what we saw in the field with the stream stats or the tables.
And that's a good point, Mike. I mean, it's really valuable to have those tables, or take a look at those tables before you assess the site, to see, even it looks kind of raw and it looks kind of beat up, but boy, if those dimensions and that access to floodplain is pretty good, then maybe you want to watch it before you get in there with a piece of equipment. In this situation, as Mike indicated, that little bench that's forming there, that cross section and those benches are probably not too far off as far as depth and width and elevation, but that point bar that we said is pretty important for this type of stream had accumulated too much material, so it's now forming a terrace, which the flood wouldn't be able to access, and it can't transport that material out. And that's one of the reasons why it became a depositional area, and it's forcing that stream over. There are certain locations that we've worked with where just bringing down the elevation of that point bar to where that floodplain elevation should be will relieve the pressure on that raw bank over to the right of this slide. So yeah, those tables are really valuable in the assessment to begin with.
And so this is the next curve upstream of that. As you can see, again, the water is pointing directly at that raw bank. And we're looking at, like, where do we stop? How far do we even keep walking at this point, right? And so we got up to the top of that point bar and we see this. We're like, okay, typical response of a lot of dozer operators would be, well, we got to doze this whole stream. We have to do all of this. We have to keep going. And what we looked at here was like, well, if we even are going to work this far, this is where we're stopping, because now we're far enough away from the infrastructure. There's no fields or open houses. the corridor is there, even though it's completely plugged with sediment. I don't think we need to go any further because we're past the impact of what we're addressing, which is the alignment with the bridge. And so we looked at this tree and we said, well, maybe we should get rid of that tree and we could dig it out and use it down below. And then we said, well, we don't need to go up there, so maybe we'll just cut that off. The roots are still, half of the roots are attached in that bank, even though the tree is down. So they're holding it together a little bit. And so we said, okay, how likely is that tree to come loose and get to the bridge? It's far enough away. If we have time, we'll address it in one way or another, but we'll come back to that. But definitely that's our stopping point. And so, because you have to stop somewhere. You don't need to, and you shouldn't doze the whole channel. There's obviously an issue with sediment here, and it's pretty plugged up, but there is plenty of capacity within that corridor that you see up above. And you know, we don't have the time or the money to address the entire stream. Let's just deal with what we have to deal with to move on to the next site in the case of after a major flood event. And so now let's look at the video. We've got a drone video from this point going downstream. So as we view that video, Mike and I will kind of talk through the thought process. Essentially, now we've walked upstream. Now we're going to turn around and walk back downstream and kind of rethink and think through kind of everything that we've been talking about, and like where to work, what work to do, what needs to be done. And, you know, it's taken us probably just about the same amount of time as it would take us to walk that section, and we'll be walking back down. And so, you know, we're talking about 15 minutes of site evaluation, and then we should kind of have sort of a plan from that. So now let's take a look at that video. So now we're heading back downstream. You can see that point bar on the right and how much pressure it's putting on the opposite bank. So, you know, like what we're thinking is we don't want to straighten the channel, but we want to realign it so it comes into that bridge better. So we can essentially flip-flop the channel off of each of these curves and move it over a half of a channel width and reconnect it to its floodplain and get that channel alignment back in order. And actually there's Mike and I walking upstream right there. You know, this curve we were concerned about, again, because it's pointing it right into that washout area.
Yes, and we're also looking at how tortuous those radiuses are. So, you know, again, that's where an aerial view really gives us a good perspective is, you know, what would we expect in this valley, you know, and what kind of sinuosity. We're also looking at that cross section and that elevation to the top of bank to get that bank full elevation to see how much material is present.
And you can see here how that's pointing directly at the road, and the alignment is way off from the bridge. So, you know, that was our main concern. And, you know, again, this is I don't know, maybe a 300 to 500 foot length from here to the top of that third curve, which is quite a bit longer than you'd normally want to work in a emergency stream intervention type of project. But we're looking at this and thinking that we have to address this because there's our bridge, you know. And so this is the infrastructure that we're looking at protecting, the bridge and the road. We don't want to allow that to plug up with trees, debris, and sediment. We don't want the stream to realign itself to be not even at the bridge anymore. And here's another good point to make is this is Appalachian Creek that you're seeing in the background there. And so this is where Long Creek enters the Appalachian Creek. So we're in a transitional zone where we would expect to see sediment starting to drop off. So we have to consider that in everything that we're doing also, that, you know, we're going to be in a place where we're getting a large amount of sediment and sediment backing up. So we want to just tread very lightly in the stream. And you remember that anytime we do any work in a stream, the stream is going to react to the work that we did. And the closest that we can match to what the stream wants to do with what we want to do, the less readjustment it'll have. It'll adjust much less violently against us. Okay, so now we've walked the site and we've answered some of these questions, right? So what are the damages? What's the issue? The erosion of the stream bank, the stream heading towards the road, excess gravel deposition, woody debris, potentially mobile, right? So we wanted to deal with that. What's the risk if nothing's done? Well, the stream could wash out to a place where the bridge isn't on the road. We could get those trees plugged in the bridge and causing a plugging of the bridge or a washout. What's the priority? The priority is high. We got to get this done before we get another flash flood or major rain event. You know, what are we going to do? We're going to realign the channel. And again, this is, we don't want to straighten that channel because that, you know, based on what we've talked about in our experience, that does not work. You just doze a straight path and the stream's going to readjust to put those meanders back in. So now you've loosened all that material. You've potentially made it too deep and too narrow or too wide. And so, you know, all the host of issues that could come with that. So we aren't straightening, but we can lessen those curves a little bit, and we can keep it kind of within that corridor to align that fast flowing water to be more where we need it to be, which is the bridge opening. So that's essentially what our plan is. And that's, you know, what we're looking at. So what do we need? A dozer, an excavator, permitting, covered under the nationwide permit number 13. And so, you know, now we can fill out a little bit more of that information that we're looking for. So now, you know, getting into the specifics of planning the work and channel sizing, what are some of the questions that we want to ask, that we want to be concerned with, right? What did it look like before? Do we know what it looked like before? What should it look like? How far do we go? We kind of talked a little bit about those. You know, we're going quite a ways here, but we have determined that we really need to for a number of different reasons. You know, how deep or wide is it? And now we'll get into that in the next couple of slides with our channel sizing. You know, is there a place upstream where the gravel deposit or the issues end? And in this case, like upstream, it's still completely choked and plugged with gravel, but there aren't impacts to the infrastructure and it's far enough away that we're not going to go any further. We're not going to wholesale doze the stream channel because we don't have time or money to do that. And it's not really going to be a benefit for the amount of work that we need to do. You know, things to be cautious of, things we want to look for. What are those bank full channel dimensions? Ideally, we find an undisturbed section that we can measure how wide the stream should be. In this case, we kind of didn't have that, but we got some measurements anyway. You know, if we're removing material, the minimum necessary, we want to watch out sharp angles and corners. Like in this case, we've got that tortuous meander. You know, that's obviously the water is having a hard time because it's wanting to realign itself to a different alignment. You know, where do we stop? And the oversight is one very important thing. Is there's really excellent machine operators that do really good work, are very intelligent people, but sometimes you get behind that dozer and you just go and go and go. So that's where you have to have the oversight. Someone may not have ill intentions or they think they're doing the right thing and they just want to keep going and going. So having someone there on site during the work to tell them when to stop sometimes is important as well. So now that we've evaluated the site and identified our basic plan, we're going to look at the channel size. And this is stuff that Mike and Jeff covered in the classroom portion of the presentation, but I'm just going to run through it really quick and give you some of our reasoning and how we did it in this case. And we'll come back to this because we ended up getting some drone footage after we've had a fairly significant flow event, and we could talk about our channel sizing and what worked and what didn't work. So, you know, here's one simple way is go to USGS Stream Stats online. It's a web application, and then this is just the picture on the screen is just like the output result of that. You go on the screen and you scroll in and zoom in to your place on the map, and there's a few buttons to push to get to that. There's directions on Stream Stats of how to use it. It's really simple. It's just clicking some buttons and zooming into where you're at, and it will give you this output. And so here we have the bankful depth and the bankful width based on the watershed area that it has determined from our point on the map where we are. and this location is 2.84 square miles. So this says bank full width 26.2 feet wide and depth 1.34 feet. Another method to find the channel dimensions is to use the topographic maps that the Upper Susquehanna Coalition has available, and you can keep them online as a PDF file, or download them to your own computer, or you can print them out and have them somewhere in your shop. So in this case, it's a color-coded system that shows a range of drainage area for your spot on the map. And so here's our site, and you can see it has this specifically colored line. And if we come down here, we're in the 2.5 to 5 square mile range. Okay, so we've already done stream stats, so we know we're 2.84, but 2.5 to 5. So then from here, we take that number, that 2.5 to 5. And if you look in your manuals, the ESI training manuals, all this information is in there as well. And I'm not sure which page it's on, but this regional map shows us which region we're in for the stream tables. So this is where we are, and we're right on the edge of the southern tier in the Susquehanna region. And I often find along this line, we can kind of use one or the other depending on what the current condition of the stream looks like. And again, looking at what's happening in the stream and matching it up with these calculated numbers is the ideal way to really come up with the closest numbers that are going to give us the best value. And so in this case, we looked at both the Susquehanna and the southern tier region, and we compared all of our numbers that we had. We measured in the field. It was 27 to 28 feet wide, that spot that we showed in the previous slide. Our drainage area is 2.84 to 5 square miles based on the topo map. And so we looked at the two tables, and in this case, I picked 5 square miles on the Susquehanna because I felt like that number 27.8 was as close to kind of the average of all the other numbers we looked at. The easiest way to go about this would be to say 2.84, that's 3 square miles, and so you pick one or the other. In this case, if we went 2.5, 20.4, and that's different. Stream stats was 26.2. So you can see none of this is perfect, but it's getting us closer to that actual dimension that the stream will be able to heal itself from. So, another way is like if your soil and water district is able to help you, you can call them and they can give you these numbers. But essentially, you can see this is all laid out in the manual, and it's a lot more clear than kind of how I have it on this slide, how to go through this. I just wanted to show the comparison of stream stats with our field measurement with, estimating based on the two tables that are really close to each other. And so, this is sort of what your output should look like. This cross-section diagram is essentially something you could hand to the operator and say, here, that's this wide on the top. It's a 3-to-1 side slope, trapezoid channel. You have your minimum floodplain. That's where your bench height you want to be. And in Tioga County, I've developed this, I put together this form from just a PDF document that I can just fill out these numbers and print this out and hand it to someone. And that makes it a lot easier. I've also taken it one step further to calculate the bottom width. And that comes into play later on as a much easier way to kind of talk about things. So this is our basic diagram of our channel dimensions. And so, here we have 27.8 top width, 16.6 bottom width. And again, the bottom width is, I've explicitly calculated that because sometimes it's easier to know what your bottom width is before you even get to your top width. And this is a sheet that can be handed directly to the operator, to the permitting agencies, and it tells us all that we need to know. So now we're looking at our final plan, what we're actually going to do out there, our layout and our alignment. So, the main point in the channel sizing is get that stream width, depth, and floodplain as close as you can to a natural place to allow the stream the least amount of adjustment. Like, I'm going to say this a number of times. Anytime we touch a stream, it will readjust to the work we do. The idea here is to do the least amount of work necessary so that the stream ends up doing the least amount of work necessary and adjustment after we've done the work. We want the stream to adjust slightly to what we do, not violently. So this is where we decided we would start the work on the low end of the big washout, because that is going to take the most amount of fill. And in this case, we intend to fill up to the height of that adjacent lawn, because that technically shouldn't be part of the stream corridor. That floodplain is within that other corridor to the left of us here. And so we're going to need quite a bit of fill to get this filled in. And so we wanted to start there to make sure that was our critical point. If all we had time, money, or available fill to do, that's what we would do. And if we had to walk away, then we've done the minimum necessary. So that's why we're going to start there. So on site for construction, we have to dewater. We've got to get the water bypassing our work site. So we're looking, we can cut a temporary diversion channel over there on the left side of the stream, stockpile material in the middle, and then start moving it over. And we're not working in flowing water. And that's, you know, something that's good about this site is we have plenty of room to do that here. And here's just getting started, you know, initially cutting that diversion channel. He started on the downstream end, is just working his way up to here, stockpiling to the left of him. And then once he gets up to the top, we will dam off the flow of that flowing water and send it to the right in that diversion channel. So then we can go to work on moving the bulk of that fill over. So here's the filling in the washout, and we're bringing it up to the existing grade of that lawn. And then once we get over to where the tree line used to be, then we'll slope it down and start building our benches within the channel. But for here, we're just bulk filling to prevent the stream from washing this out again. And then here's a drone view of the top edge of the washout site and the next gravel bar upstream. Right here, you can see we're placing some root balls, and those are debris that were on site there just above us on that curve to the left. And we're using those root balls right at that critical point. You can see where the main flow of the stream was hitting right there. So the debris that we do have in the root balls, we're going to place them right there at that critical point and, you know, get those in place before we backfill the rest of that. And then above, we're clearing snow from the gravel bar above, because we're going to need to source more material from that gravel bar to continue filling that lower washout. So since we did need material from that upper gravel bar, the guys decided that it was going to take way too long pushing with the dozer because it was quite a far of a push. So time to call for a truck. Sort of an example of the, you know, midstream on-site changes that we needed to do, and luckily something was available and we were able to continue work right away. So here the washout is filled up to grade. You can see in the distance here, this is our the Upper Susquehanna Coalition's Maruka rubber track dump truck. That was available for us to use, so we brought that on site, though as you can tell by the material you're seeing in the foreground here, it would have been fairly easy to access with an actual dump truck and just flatten the road with a dozer. So we could have just used an actual truck to move that material, or a front loader would have easily been able to help move that material as well. So, you know, I just wanted to point that out, like that's a specialty machine that was available to us, but wasn't necessary. It's just what we had. It would have been able to be done with a truck or a front loader. And so we're doing the bulk of the earthwork first, and then we'll come back through and do that final clearing, grading, and bench construction within the corridor. Again, we want to make sure we get the bulk of that material moved first, so that our alignment can kind of be, we can see the alignment afterwards. So now that that section is complete, we're able to move up to the other section. And as you can see in our plan here, we want to realign those curves. And so we've got quite a bit of fill to put on our right side bank full bench. So I'm just gonna run right through this next section. So here we are with the water diverted, and we're moving the rest of the material over to fill in that tortuous meander on the left. And the dozer is prepping to bring more material from up above, because essentially we've had to hopscotch material because we needed so much for that lower washout. So now we're taking, so we took some from this middle bar, now we're going to take some from the upper bar. And all throughout this, we're keeping in mind our elevations for our floodplain, for our bank full bench. And by moving this material in this way, we're setting ourselves up to allow the stream access to a floodplain again. So this is just a photo of the snow cleared and a little roadway put in from the uppermost gravel bar, getting ready to move material down. And here on the left, you can see we're beginning to just put the bulk of the earthwork in for that bank full bench on that outside of the curve there. Again, just roughing everything in. We're getting the rough bulk earthwork done first, then we'll start aligning and shaping the channel. And this is a personal preference of your operators, how you want to go about this. This is just the way that we sequenced it. There may be other ways, there may be more efficient ways, different preferences, but this is the way we just happen to do it. So it's not, you know, our method isn't the only way, it's just the end result. What we're looking for is ideally what we can all agree on at the end. And here you can see we've got the bulk of that earthwork on that outside bench in, and we haven't started cutting dimensions. Now we're going to move on to the upper curve. And again, here we are on the upper curve with these large trees and root masses. So, you know, we decided instead of moving those around a whole bunch, we just essentially crushed those down in, and we were burying those in our new bank. So in this case, we're actually going to slope that bank up to the top of the bank, down at maybe a 3 or 4 to 1, and then start our bank full bench from there, anticipating that the stream probably will erode back to that point at some point in the future. But now we've created a little bit more of a barrier to erosion, and you know, essentially that we've given the stream a chance to slowly heal itself rather than catastrophically move again. So here again, completing the bulk of the earthwork, getting that filled against that outside bend, and starting to work on where that channel alignment's going to go, you know, a little bit more to the center. Again, not straightening, but flipping that channel a little bit. So here we are with the bulk of the heavy earthwork completed, and now they're working in tandem to start putting together the actual stream dimensions, the bank full dimensions. So they're sort of cutting and still moving material, but also really roughing in that channel shape and dimension at this point. And then we have a video of that. And so you can see here, they're still doing some of the bulk of the earthwork, but while they're cutting the channel in, because we've reached that point in the project. On the left, you can see we still have our water diverted, so we're not working in the flowing water. And so they're kind of working on filling the bank, creating the bench, and the channel dimensions all at the same time. So here the channel dimensions are roughed in. We still have our water diverted around the site. So you can see it's not perfect, but that was one of the things I wanted to mention about the bottom width of that channel. One of the easiest ways that I found to communicate how wide the channel needs to be is using that bottom width number. I say, how wide is your dozer blade? 8 feet wide, channel 16.6 feet wide. It's about 2 dozer blades wide. So during construction, you don't have to get out and measure all the time. If you have, and any operator, I know you guys can do this and have been doing this. So just, I want to add that we don't have to always be surveying or measuring while the work is being done. You just know how wide your dozer blade is, you know what that bottom width is, and you can go ahead and get those dimensions roughed right in. as I was walking the site while they were working up above, I noticed that the slope right here was a little bit steep. That concerned me, that if we leave the slope too steep, we could potentially send a head cut upstream. And now that we've loosened all that material, it would be that much easier for that head cut to work its way upstream. So, you know, we don't want to make things worse. And in that case, if we leave it too steep, we could cause a lot of that sediment to become mobile and go plug the bridge. So that's completely counterintuitive to what we're trying to do. So we want to pay attention to stuff like this. Anywhere, if you leave a drop off or a really steep section, that is going to help the stream react negatively and cause a head cut to go upstream. So because of that, once I noticed that, and they had the essentially the bulk of the rough in of the channel on the upstream curve, they decided to work their way from downstream to upstream to switch, because we want to be able to chase that slope. So in this case, we started on the downstream end, and so now they're working on roughing in those channel dimensions from the downstream working upstream. And something I want to point out here is right in the front left of the photo was a place where we decided to stop. So where I'm standing is in a pool of water. Just above that pool of water, you can see that riffle where the stones are exposed in the channel where the water is flowing. So that is an example of, you know, that's a natural riffle that was there before we started work. And it is a little bit steeper there, but that is all imbricated stone. So all of that stone in the bed of that channel there is shingled in together. So we wanted to stop there because we figured that would help hold the rest of the site together once we left. Because if we loosen everything up, it has a chance to become more mobile sooner than a bank fully bent. And so that was our stopping point on the downstream end in consideration of our slope stability. So the middle segment here, the rough-in is complete. And notice the bench on both sides. So that's our floodplain area. And that can be accessed by larger flows at the incipient point of flooding, one of the definitions of bank full. And we've provided, you know, quite a bit of space. You see now we didn't straighten the channel, but we did lessen those curves to get our alignment in place a little bit. So now we're doing a measurement check. What's the, you know, are we there? Do we have it? And in this case, there was a little bit of tweaking to do. We were pretty close. At this stage, if you had to move on and go to the next site immediately, we would call this close enough. We were within a foot or two of our top width. We have the bankful benches in place. We had a little bit more time to tweak it a little bit more, so we did. Again, in this case, the photo here that I'm seeing, if someone showed me this, I'd say, looks good, move on to the next site. But since we had the time, we had the ability to get the measurements, we wanted to make sure we had those dimensions uniform. Another thing that we did on the site, because we had the ability to do so, is we went and cut some live willow stakes from another site that we had previously planted in, and we trenched those in on that low bank where the washout was for a little bit of added stability. We had talked about, before we even started work, evaluating the site, eventually we might need to put some riprap in there or some in-stream structures, rock structures, to redirect the flows away from that erode bank to keep them aligned with the bridge. But we were in the emergency intervention mode, so we didn't have time or money to do that. So the Willows took one guy an hour and a half to cut and haul to the site and get them installed. And the excavator essentially just trenched in the bank down to the water table, and we threw them in and evac them. And this is just a view of where those 3 lines of willows that we put in there, with the anticipation that if they are able to start growing, that they will help hold that bank together a little bit. And now we've got another video coming up next of the kind of the final cleanup and walkthrough. So here on the downstream end, you can see that imbricated or shingled riffle on the very bottom as we're passing now was our stopping point. And you can see our benches on both sides. And In this area, we actually did end up taking a couple of small trees out on the left side because they were impeding the flow, and that's potentially part of why that eroded there. So we did take those out, and that's also we used in that bank for stability. And that gave us a little bit more room there. And so right here, I'm talking to the operator and reminding him that we don't want to pile any more material up onto that existing bank there, that we want to kind of keep as much space there as possible, and that bankful bench is a little bit high on the inside there. We want to make sure that the stream has an opportunity to access that inside as much as it does the outside there, and that it's a little bit narrow just up here. So I wanted to get him to get that width back opened up in this transition. And we anticipate that the stream will move. It will erode to the right here on that outside bend. And, you know, it will form a gravel bar on the left side and here on these corners. It will want to reform those point bars. It will migrate a little bit, but we hope that through using these methods, we've put it in a position where it can do that without violently adjusting and reacting. And we decided to leave that tree, and we'll keep our eyes on it. It'll be for monitoring in the future. So now we have another video of about a month after that, where we've had a couple of significant melt-off and rainfall events that were near or just about or just below bankful. So enough of an event to start moving material in the channel. And then we can run through that and talk about kind of what changes the stream did make, and you know, what we got right, what we would have done better knowing what we know now, what we need to worry about. This is sort of the follow-up section. So here we are starting upstream. You can see on the right here, it did begin to form a new point bar within that active channel, as we expected, and it's going to want to start cutting a little bit. One thing we noticed is as we round the turn here, it did begin to form a center channel bar there, which is not ideal, though it is still within that bankful dimension. You can see it's kind of cutting around on the left side. We anticipate that it's going to end up cutting around on the right side. Right now, it's not a concern, but we're going to keep an eye on it. Essentially, the channel has stayed in place where we put it through those two events. And as you can see here, it's not immediately slamming against that washed out section. And it is still coming within alignment with the bridge. So we've met our goals. It just maybe there's another center channel bar just down below, just above the bridge here, you can see. So, you know, we got the dimensions maybe a little bit too wide in this case. And I guess that's one of the lessons is, you know, essentially maybe you want to go a little bit narrower. If you're going to error a little bit narrower rather than wider. The stream will cut itself the dimensions it needs. But in this case, we're going to keep our eyes on it. And, you know, now you can see there is a little bit more deposition under the bridge there, where the DPW has access on the other side of that, easy access. So now if there is any maintenance needed, it's within that right of way. It's within the realm of, you know, they can deal with that. And this, I do not believe, has reached a threshold of needing additional any work right now. They do plan to come back and reset some of those riprap stones. So I think we're in good shape here. So here's a side-by-side of the aerial views from our initial site visit and assessment, essentially the completion, the final cleanup of the work, and then after a couple of those storm events. So Mike, I think you and I were having a discussion previously about those center channel bars and kind of what we could look at, and gauging the level of success of the project.
What's really nice about this site, especially nice that we might not have on every site, is that we had a nice stream corridor working, so we could recreate that floodplain, within that channel boundary, and get that width that stream depends on. And the other is, I think we've heard observations from other folks that those table and stream stat dimensions sometimes tend to be a little bit wide. And so, as a result of, as you've already pointed out, well, that material's been shifted and sieved around, and so those fines will start to settle out, and they'll start to be deposited and repositioned in places. And until you get a few storms that actually are bankful events that start to mobilize all that material and readjust them, that'll happen. And so we need to keep an eye on that to see if we've got those dimensions right. So, that's a good learning piece for that. Again, great place to try this. If we can increase that transport, if we can get that material moving through along with the water without cutting and ripping at its banks, it's a successful program, and we didn't have to use a lot of heavy, rock or material that's expensive and time consuming and takes a lot to install. And the other thing, that's nice to mention is that, a lot of times take a look at all those gravel deposits and you want to haul them away. We were able to utilize all that material on site, and I don't believe you had to pull any of that material away, did you, Mike? Or that was all utilized on site, recreating those channel dimensions and those floodplains. And so you incorporated all that gravel material without having to haul it anywhere.
Yeah, that's right. We were able to do that. And part of what helped us in this case was that the giant washout there in the lawn. But I mean, that is a good point. And in most cases, whether it be an ESI type project or a stream restoration that we're working on, we rarely have to haul material out. We can often use it, and that also means using it within the corridor, not piling it up on the stream banks, because that's a common misconception is, well, if we can't haul it out, let's pile it up on the stream bank, and that causes a whole nother set of problems. But we've been able to successfully use the material within the corridor, within the floodplain, and benefit the stream. Now, I will point out in this case, there is material now being mobilized down to under that bridge, right? So that is a concern. The DPW has an existing maintenance program with that bridge. So I'm not sure if it was before, I think it was before the final photo here on 330. They were down below the bridge, and they had removed some material from where it meets Appalachian Creek. Now, that may or may not have anything to do with the mobility of the sediment within our site. It does not appear that a head cut went up through, but just saying that this is, the center channel bars and a little bit of deposition down at the bridge. This is not a perfect system, and I think that's something that's important for us to be explicit about, that, we're not saying we're going to solve all of your stream problems by using this method. What we are saying is we're going to solve a bunch of your stream problems by using this method, but nothing is perfect. This is based on science, but doing the work is not a hard science. So, it's a varying degree or a scale of success in this sort of thing, where we know that straightening or widening would cause the stream to react more violently, and you'd have to be back in there sooner to repair it again. Or if you were only able to do some of this, it could potentially cost you more time and money. And so in this case, it's good that we're having some channel adjustment to show you, because we expect it to adjust. We didn't necessarily expect it to start forming these center channel bars, but it's still a success. The metric of success here was preventing it from continuing to erode away from the bridge alignment. Well, we have succeeded in that. If you look at the photo from 330 here on the right, you can see that our willows are intact. Our bank there is intact. Our bank full bench on the bottom of that bank is still intact. So, essentially our main priority was that, aligning the stream to the bridge, preventing the woody debris from being immediately mobile. So even though we have some adjustment that isn't ideal for us, so far the project has succeeded in our goals.
Yep. And keep in mind that this is an emergency stream intervention. So this is emergency maintenance, type of efforts. We'll monitor this. We'll keep an eye on it. If needs be, make some tweaks. But the whole idea is that if we have to go in there, if we have to do some kind of emergency maintenance, we do it in a way that's not going to make things worse, that it's going to actually facilitate, jump starting nature, getting back to some kind of stable type of situation. And this whole region, that we worked in is really a depositional area. That's what nature's doing. If there wasn't a bridge and a road and some houses there, that'd probably be a big delta area where it hit Appalachian Creek. And when that main creek is high, it's going to cause backwater, and so that material's always going to deposit out there. And if we were to walk further upstream from where we did the work, you're going to notice that the landforms are starting to get tighter and tighter together and confining that stream channel, and so it's going to straighten out more and carry a little bit more energy. So it's going to carry that material, and as soon as it hits this little stretch that was worked in, it's going to try and drop that material out. And so this is the type of areas that we come across all the time, that are impacting on the infrastructure that we have built around it. So again, the idea is to minimize that maintenance, to do that maintenance in a way that's going to facilitate healing that stream channel, and hopefully we'll have to do a whole lot less maintenance. And it'll improve even more once that vegetation comes in on those floodplains and starts to bind all that material together. That channel that was put in there is going to stabilize even more.
Yeah, I'd like to also add that I'm just thinking, I don't want us to sound like we're contradicting ourselves as far as the removal of material from the channel, because we talked about using it all in this reach, and then I mentioned that the county DPW has a maintenance program to remove material from below that bridge. So that there, ideally we don't remove. There are absolutely times where you need to remove, and so that in this case we balanced that by, rather than trying to haul a bunch of stuff from way upstream or remove material, we were able to use it with the expectation that because of this is a transitional depositional area, there will still be maintenance at the bridge, but now essentially we've taken that maintenance that needs to be done is back within the right of way. And so it's not something that they have to come in and go up way upstream again. And now we'll monitor this site and say, okay, do we need to find some funding to put some riprap where it washed out? Will some in-stream structures benefit? Or like Mike said, once the vegetation gets going, are we good for a while? Is it good for a long time? So I just wanted to point that out, that it oftentimes it sounds like we're saying both things and contradicting ourselves, and that's not what we mean. We mean, just like as we move on to the next slides, which are the key take-home messages, is where to work, what type of work to do, least amount of time and money. How do we do the work so that the stream adjusts to us the least amount possible?
I think that sums it up perfectly, Mike. I mean, the whole idea of this program was recognition that, yes, in some cases we need to do maintenance, but how do we do that in a wise and sensitive way so that we don't make things worse?
So the key take-home messages from this segment, and I think, from the larger training as a whole, is you after a flood event, you prioritize where to work. You assess the stream using your itemization sheet and any other resources that you have to do that assessment. If it's with some places you might think it needs work, but if you look at it a little closer, you realize it's not going to need work. In the case of looking at those areas you have prioritized, just like we did, we kept walking further and further upstream to see where does this problem end. And we may not have had to go as far as we did, but walking that extra distance just to get an idea of what's going on just around the next corner is really important to know, because you can really, sometimes you can find that your work is in a much smaller area. Sometimes you realize that if you don't go a little farther, you're going to be doing work for no reason and you'll be back again. So, again, we want to look at all these things. And ideally, you find if you're realigning or redimensioning the stream channel, the ideal scenario is finding that undisturbed reach right around your project area, because the stream is really the best teller of what it wants to do. So again, this is repetitious, but this is one of the most important parts is, we want that stream to have access to the floodplain wherever possible. That's one of the ways it slows down, reduces its energies. We want those dimensions as close as possible so that we can move sediment, water, debris through with the least amount of damage or adjustments.